Hello, everyone. My name is Cassandra Nickles, and I'm here to talk to you all about the Surface Water and Ocean Topography Mission, or SWOT mission. Thanks so much for listening in. So SWOT measures global ocean surface topography and land surface water extents and elevation with great accuracy using interferometry technology. It launched in December 2022. It has a 21-day orbit cycle, which means you get an average of 2 observations per cycle in your region, and it's global. Almost global, 78 degrees north-south coverage. You can find more information at this website in the corner right there. But hydrology measurement simplified, we have SWOT flying up above, collecting height, width, and slope of rivers, as well as height and extents of lakes. And so from that height, width, and slope, scientists have algorithms that are spitting out discharge from those three parameters and some estimations. And from like height 1 and extent 1 and height 2 and extent 2, if you subtract out what SWOT sees from one timestamp to another, you can get volume change of your body of water. So if in the future, probably about January, we'll have a river flow or discharge and lake reservoir volume change within our products. So the requirements for SWOT, though, are that rivers be greater than 100 meters wide and lakes greater than 250 meters by 250 meters. We are encouragingly seeing rivers less than 100 meters wide, though it's SWOT. So in future products, we'll hopefully have a smaller river width as a threshold. And this is just a global snapshot of where we have data. So SWOT river reaches, so a river reach we define as a 10-kilometer stretch of river, and you have information based on that 10-kilometer stretch of river for the entire river reach. And you can see it's all over the world. We have some in North America, South America, Africa, Asia, Europe, all over the globe. Yeah. So hydrology relevant level 2 SWOT data products, we have the Pixel Cloud Net CDF. So that looks like a bunch of points aggregated over wherever SWOT deems is a body of water. You can see a close up here. We have a raster net CDF. That's the format of the file, and that is derived from that pixel cloud. So they take all the points and then they aggregate it in a raster. We have the river vector shapefiles and lake vector shapefiles, and it comes in like a SWOT swath. So how SWOT passes over in a stripe basically on the globe. And when you look close up, this is what the river vector shapefile looks like. It's just a vector product. And then you can also see the extents of the lake vectors as well. And this is an example of what the lakes look like all over the globe in one single file. So what does that look like? What does the real data look like? Here you can see confluences of the Ganges, Brahmaputra, and Meghna rivers in Bangladesh. They're South Asia's biggest rivers, and together they flow into the Bay of Bengal, and flooding is definitely guaranteed every year in that monsoon season. So SWOT captured some of that flooding. I should note, though, I forgot to say this earlier, that the latency for the products is about 3 days. So from when SWOT sees the observation to when you can actually get and download the data is about 3 days. So it's harder to do real-time analysis. But you can see after the fact, like, oh, wow, that was a flood. Here's a fun little snippet in what you can see Washington, D.C.'s reflective pool from space. You can see the little pixels right there with this raster product. SWOT also captured the Nile River flowing through Cairo, Egypt. You could see the raster product in detail, and you could see the water surface elevation that it captured. So SWOT can be used for a lot of different applications areas, including floods, reservoirs, drought, transboundary rivers, even insurance, river commerce, climate studies, marine operations, coastal zone management, fisheries, you name it. You can look in more detail at that website at the bottom. I want to talk to you guys a little bit today about different areas that I've seen people using SWOT data. So their first example is the Texas Water Development Board, TWDB, in Austin, Texas. They're using SWOT to estimate volumetric evaporative water losses from unmonitored reservoirs in Texas. So they get that surface area from SWOT, and they compute statewide evaporation losses. So that evaporation minus precipitation using that surface area. And they're doing it for about 200 major Texas reservoirs. So this isn't just happening in Texas. We've got some people looking at operations in Egypt as well. So Alexandria University has a project improving dam operations and building stronger capacity for using SWOT observations in monitoring surface water resources in the Nile River Basin. They have this awesome tool called NIBRAS. And it's a satellite-based framework to facilitate the understanding of water management issues associated with reservoir operations in the Nile River Basin and provide a basis for evaluating potential solutions. So they're incorporating SWOT data products into their dashboard. Also, IIT Bombay has a work in progress that they're using SWOT data. They're hoping to have a lake data inventory from SWOT, looking also at flooding on Indian rivers through the discharge estimation. They want to extend historical gauge network over Indian River reaches and do some model calibration. And they also have a mapping toolkit that they used with a prior satellite, Sentinel-1, and they're hoping to bring SWOT data into that as well. Another project that we have is Water Insight. It's a Swedish startup that they developed SMS and WhatsApp tools for hydrology gauge readers. So they put these rulers in different lakes and regions in Africa, Malawi, Mozambique, Sierra Leone. And they have people text in smartphone observations of the river and rainfall levels, and they send that to a database for government operational agencies. And they're hoping to compare SWOT data to all of these citizen science smartphone observations. They're also looking into flood thresholds and equipment inventory. That's the basis for their project. I also want to mention this SWOT Viz dashboard. So you might be asking, okay, great, Cassie, how do I access SWOT data? Well, you can view SWOT River data time series and apply quality filters without actually even having to download. I'll show you in a bit how you could download if you want, and we have a ton of resources on how you would do that using code, etc. But if you just want to get your feet wet and say, wait, how would I use SWOT data? What does it say for my region? We have a SWOT Viz dashboard that I'm going to show in real time right now here. So if you go to that website, swotviz.quasi.io, and you could zoom into any particular region, let's say I'm interested in South America, then I can go to a river and say, what does this one look like? And plot it right there, real time, and it'll show you all the SWOT observations that they have for that region, and then give you the data quality from the science, if it's good, if it's suspect, degraded data, or bad. So you can say, actually, I don't want any of that degraded data in there. Oh, great, that looks like my time series. So this is a very accessible way to look and see, oh, what's SWOT data saying for my region? Okay, let's go back here real quick. And then also, we have resources, tips, and tutorials. I want to show you guys real quick what this looks like. This is the PODAC Cookbook SWOT chapter. So it gives you a little bit of a background on SWOT, and then it shows you all these different ways on how to search and download for SWOT data. If you want to do it using code or the command line, how to do it. It gives you tutorials on how to access and visualize data. So if you're looking to access hydrology data, we even have in the cloud versions of it or locally, it'll give you a whole Jupyter notebook that you can explore and say, oh, I want to access this shapefile. How would I do that? So if you don't want to use this awesome dashboard right here and you want to get into the more nitty gritty of it, we have a ton of tutorials for you on how you would do this. Okay, and then let me go back to my slideshow. We have a SWOT user handbook. So if you want the nitty-gritty, you want the details, all the descriptions of all the SWOT products, the instruments that were used, the measurements, what all of it means, the geoid, all the references. Here we go, a 200 plus page document of the SWOT science data products. One last thing that I wanted to just make mention of. So that dashboard that I showed earlier uses this awesome API that produces that time series. This is how it gets a time series. So if any of y'all are out there and you're like, I want to populate SWOT data in a web dashboard for River Reach, or even just like make time series ingestion easier into any of your models or faster analysis, this is the tool for you. What it does behind the scenes is it takes all the different shape files that you have for your region. So you like a pass over the river. And if you just have a particular river reach ID that you're interested in, it'll basically, you just have to input that river ID, and then output will be a CSV or a GeoJSON that you can just automatically have in a time series. So basically what that dashboard is doing, this is the tool that they use to get it there. So if you're looking for something for your use case, take a look at this documentation and tutorials. Oh, yes. And then we have a GitHub collaboration space called SWOT Community. It's a code space for anyone in the SWOT mission community. We share experience, code, research, all that and more. There's hydrology sections and even oceanography sections if you're interested in that. And then the SWOT Applications Working Group, SOG, we're announcing that you're invited. We want to build connections and awareness among people that are participating in applications work related to SWOT. We really want to spread expert knowledge on how it should be used and communicated. And this is really a working group to move beyond understanding the data toward using it for societal benefit. And what does that look like practically? Well, we're having quarterly virtual gatherings to communicate what we're doing in the application spheres and even brainstorming ways to synergize among all of us. We haven't started up this group yet, but we're looking to do so soon. So if you're interested in being on our email list or being on the invite, please contact me at cassandra.l.nickles@jpl.nasa.gov. So with that, thank you so much. Contact me or my colleagues if you have any more questions on SWOT. And if you're interested in being part of the SWOT Applications Working Group or the SOG, please email us. We'd really love to have you there. Thanks so much.